Hey guys, Vasily here from Converge. I'm an AI architect working with Converge.io, and today I'm going to walk you through, in this video, a brief demonstration of running experiments in Converge and what that means. So, to kick things off, you can jump into a particular project inside of your Converge environment to follow along, or just watch as I go through it. Here in this MNIST project example that I have going on here, I have some files in the file system. You can develop these in the workspace, you can upload them via the CLI, or you can link a Git repository. All are valid avenues for getting files into your project directory. Once you have files in your project directory, what you're going to be using in an experiment is a file that actually produces some output and has a loop structure already inside of it. Typically, that would be a machine learning model that you're training, but it's not necessarily it's not limited to just machine learning models. You can run simulations. You can run really anything that loops, and Converge will then run that experiment for you and track those results. And so in this case, I'm going to go ahead and there's several models here to choose from. I've got one here that's going to be training a CNN, so we'll stick with that one. And we're operating on the MNIST data set, and we're going to be basically taking a standard model training script. You can really go grab any example you want, take a script you already have that trains a model. Converge is a code-first platform, so you're not restricted and you don't have to make any fundamental changes to your code for it to work with Converge. In this situation, I have added a little bit of code that's going to be exporting an additional model artifact for us at the end of the run, an FP32 Intel optimized model that we can then use for inferencing on Intel hardware, and that will then take full advantage of those hardware investments. Now, at the end of the model, we also go ahead and save that Intel optimized model as well as the CNN.h5 file. And you'll notice I've got some print commands to look at things like accuracy. I've also gone ahead and added print commands within the loop itself. And so if you look here, I've got converge underscore line chart underscore, and then a formatting for loss training and for loss test. Now you can choose to actually log out really anything that you want. This is an example of using print commands so that while our experiment is running, these metrics will then be cast out as print statements that we can then view in the logs, but as we'll see here in the experiments, that will also be picked up by the Converge Research Assistant and will be dynamically created into line charts for us. Now there's a lot of options, and I recommend you do look at the documentation if you want to see all of the various configurations that you can support. Things like bar charts and heat maps are also possible, and you can get very creative there. You can also import Converge and use the experiments module to call the log metric function, and log metric will actually perform the same functionality as these print commands. Now, once you've added some print statements, you can also, in this case, we're showing converge underscore line chart. You can also call out print commands to converge underscore metric or converge underscore tag if you want to actually print out things once that can then be, as you'll see here in a second, tracked in the experiment as well. Now I'm going to jump over to the experiments panel, and here is where you can actually go to kick off an experiment. Now you can start a new experiment from the UI here. You can also execute it from the CLI and the SDK. So as you're developing, you can go ahead and actually kick off an experiment in Converge from your IDE. Now, if I click New Experiment, you'll see that it asks me for a command to execute. Now this can be any command that you could execute from your command line. So it can be a bash, calling a script.sh file. It can be a Scala, Java, anything that you like, R. In this case, we've got a lot of Python collateral because I've developed my code in Python. And it'll actually bring up every single file as well as the command that you would use to execute it in the drop down here, so you can actually see everything that you have, even if it's multiple directories deep in your in your file system. And so this is where you can just easily browse and select the files you want to experiment with. Here we're going to be working with the cnn.py file that we were just looking at. You go ahead and select that or type it in. You can give your experiment a title, as well as choose to attach a volume at this point. And this is where you can get more detailed. For your experiments, if your script is designed to actually take arguments as parameter overrides, then you can actually provide key value overrides here, and those will be passed to your script at runtime. So things like batch size, epochs, anything you like can actually be overridden here, and it'll be passed to your script. You can also choose to set objectives and goals for optimization and hyperparameter tuning, and Converge will then actually manage that for you and display that all in the experiments panel as it runs. This is where you can also now select a data set that you want to attach and use for this experiment. If your experiment depends on a data set that's been registered with Converge, then you are now able to actually specify, say in this example, the MNIST data set, and we can choose to take the latest version, or you can actually pair your model with a particular version, particular commit of your data set. And this is huge for reproducible data science. Reproducible results is being able to actually go back and replay these very easily on the exact data that they were trained on the first time, so you can reproduce those results. Converge manages all that for you and makes it very easy. Here you can just note the commit and select an older commit if you like, or go with the latest, or not attach any data sets if you don't require. Now, this is where you can now also select the environment that it should execute on. So for this training job, I might want a GPU, and in order to leverage that GPU, I might want to then select a particular image that is optimized to actually execute with that hardware. And so you have a lot of choices here. We could select to run on a CUDA runtime. We could, if we know we're using TensorFlow, we can select our version and go with an NVIDIA image. We can also just choose to go with the stock NVIDIA certified image that Converge ships for GPU workloads. And also you can now select a commit. So this is where you can select a particular commit, particular branch or version of your file system that contains the cnn.py file version that you would like to experiment with at this stage. Now, I can mention that you have things like scheduling available at this point, as well as various other things like setting email notifications, particularly useful for experiments, as more likely than not you're going to be running it on a large data set and it's not going to execute in just a few seconds or minutes. It's something you kind of walk away from. And so you can schedule, make that recurring, or in this case, we just want to execute it now. Once you've made your selections, you go ahead and click Run. And you'll see that Converge will automatically now just take all of those selections that you made. It'll actually allocate the compute that you selected, in this case a GPU, and select the image that you specified, in this case the Converge GPU NVIDIA optimized image that ships with Converge. And this is the experiment page that you can now track your experiment in. You're able to leave comments and attach those directly to your experiments, so you can have conversations with colleagues and collaborators about the results and findings or any issues or errors that you encounter along the way. You'll also see here that there's no files right now, but as files are produced, say at the end of the run when we get our cnn.h5 file as well as our FP32 Intel optimized model weights, those will create their own commit and will be available for us to actually clone those or merge them to the master. And so with that said, now you can actually select to have any kind of additional action taken. You can tag your experiment. Tags will show up on the experiment page and are also available for you to filter on. And that's also, if you think back as we were looking at the file, I mentioned you can print out statements with converge_tag. That will then automatically add a metric for a particular tag that you want to track. And once the model is finished training and you have your artifacts, you can also choose to deploy those artifacts into a inferencing endpoint, which you can actually learn more about in another video. And this is where you can also choose to rerun a particular experiment, export results, or stop it. Now, as this experiment is spinning up, we can go back to the experiments page and look at some of the additional functionality once the experiment is finished or once it's running. You can then compare multiple experiments side by side so that you can actually view those results in the UI right next to each other. So in this experiment that's already been run, we can see those line charts that I mentioned earlier. So printing a command to converge_line chart underscore, in this case it was loss train, loss test, val loss, anything you like will automatically then take the metrics that you're logging out and dynamically create these charts for you. These are fully interactive and give you a way to track the metrics that are most important to you as you're training your models and as you're evaluating the research that you're doing. You can very quickly, side by side, compare and understand how those models are performing over time across various metrics. Now, at the very bottom here, you can also see that we provide any of the tags that you output. So I am printing a converge_tag for accuracy, and so it's capturing that end accuracy that we're outputting when the model's finished running, so we can very quickly see which model is most accurate. You're not limited to how many tags you can produce, so this list can go on for days, and you can add as many tags as you like and that are relevant to the project you're working on, so you can very easily side by side compare and then quickly grab and see which commit the most successful model is associated with, so that you can copy that to your clipboard, go clone that, merge it to the master, whatever you like to do at that point. Jumping back to the experiments page, I'll actually then, since we saw what comparing the two experiments was like, if I just select a single experiment, I get a little bit more detail about that particular experiment. Specifically, we can understand the actual utilization for the resources that we had allocated and understand exactly how they were being used during the entire run of the experiment, while also having access to those line charts or any other type of metrics that we logged out. This is where you can also see the full log of the run, and this is fully searchable and exportable as well, so that you can view it in your favorite editor. And then I mentioned the artifacts earlier. So once your models are actually trained and the weights files are output, that creates a commit in Converge. So like everything else in Converge, everything is version controlled, creates its own commit, and here you can then actually grab the file directly. You have a clone command, the ability to merge it to the master or view the commit directly, and again you can leave comments, letting other collaborators know your thoughts and creating discussions around the specific artifacts that you want to talk about. Now, this is a end-to-end really example of how experiments work and function. You have access also to the data sets page here, and I mentioned earlier, converge_tag printing out will actually let the Converge Research Assistant automatically tag your experiment for you. And if I jump back to the experiments page here, to kind of finish things up, we can point out how that is then useful. So you see I've added that as a table element here. So anytime you print out a tag, like here epoch, version, accuracy in this case, or batch size, models that then use those tags will be able to filter on those tags as well. So you can very easily then search for a particular tag. You can select that tag from the drop down, and then you can easily filter on the values that were logged out for those tags. That can all be exported. These tables are available for you to actually export all, so that you can actually track these metrics externally. And not to mention, you can always start up a tensorboard session for any models that do use tensorboard or log out to their tensor sessions. You can then track those in a tensorboard session right here without having to do anything else. With that said, that concludes the walkthrough of running experiments in Converge. Thanks for watching.